Hello, this is Stephanie Washer, and I'm going to go over addressing, which is Module 3 from the Cengage MindTap A+ Guide to Networking. So it's basically Network Plus, and it's for our PCT 110 course at Rock Valley College, which is Networking Essentials. So this one's all about addressing. So we have Module 3 is the addressing overview. So we'll get a little overview of that. I'm going to do that briefly because I'm going to talk about each one. MAC addresses, then IPv4 and IPv6 addresses, ports and sockets, domain names and DNS, so namespace databases, name servers, resource records, DNS server software, and then troubleshooting. So we'll go through all of that in a couple of different videos. And this one's basically, we kind of like talk through it all again. In Module 1, we have the OSI model. So you'll remember, I'll give you a little overview. So we have the OSI model, it's right here. And we've got our physical, data link, network, transport, session, presentation, application, 1 through 7. And we're going to talk about the data link layer, the network layer, the transport layer. And then we're going to talk a little bit about the application layer when we talk about DNS. So the first thing we're going to talk about is the data link layer MAC address information. So we're going to talk about addressing at each one of these layers. So layer 2, layer 3, layer 4, and layer 7. And the first thing we're going to talk about is the MAC address. So media access control. That MAC address is embedded on every network card. So every NIC has a unique MAC address. It's 48 bits long. It's written in hex. So we've got 6 hexadecimal numbers separated by colons. That is incorrect. So it's 48 bits, and we've got the first 6 are the organizational unique identifier, and the second 6 is the vendor ID, so the vendor assigned. So it should be 12 hex numbers total, separated by colons. So that's there. And the switches are functioning at layer 2 as well, so the MAC address and the switches go hand in hand. The hexadecimal number is base 16. We use numbers 0 through 9, and then we have to go, because we only want one digit or one placeholder, A through F. So it can be any number or letter as long as it's 0 through 9 and A through F. And you can see, if I go scroll back up, there's a C here. There's not very many in this one that are letters, but we can have letters in there. And then the network layer is IPv4 addressing and IPv6 addressing. We'll be talking that in a little bit. And IPv4 is decimal, so it's base 10, and we use numbers 0 through 9. So that's something that we're used to. It's 32 bits. We say it's 4 octet. It's 4 decimal numbers called octets. And the reason it's called an octet is because really it's 8 binary numbers, 0 or 1. So we've got it. Our decimal that we read is 92.106.50.200, but our computers use a number system, base 2 numbering system, and so really when we break it down, it's 8 binary digits. So that's why we call it an octet. And then IPv6 is 128 bits, and so we've got 8 blocks of hex numbers. So we've got 1, 2, 3, 4, 5, 6, 7, 8. And we call them hextets, so it's 8 hextets. So each block when written is 16 binary numbers. Or 16 bits, yeah. So each one, so we've got 4, 4, 4, and 4. So 4 times is our 16, so. A port number, it's our transport layer, so that's the transport layer, layer 4. So port number, so we always put a port number on. So we have, I'm going to scroll back up. We have a MAC address. So what happens is as we come down and we start to encapsulate the data into a packet or into, we segment it and we get it ready for transport. So we start the encapsulation process. So at the transport layer, we put in the port number information. And then at the network layer, it puts on the IP addressing information. And then at the data link layer, or layer 2, we put in the MAC address information. And so we've got all of that. So the transport layer, we put in if it's going to, if it needs to go to the web server, or if it's a web server traffic, it's going to have port numbers 80 or 443 because it'll be HTTP, which is port 80, and HTTPS, which is basically secure HTTP. So, it just depends. There's a whole list of secure, not secure, but well-known port numbers that you can memorize. If you ever take a certification exam, you'll need to know them. And then lastly, we'll talk about the DNS. So domain names, computer names, host names, and we'll talk about a fully qualified domain name, and then the host name with that. So we've got our fully qualified domain name would be ftp.mycompany.com, or we could do ftp.rockvalleycollege.edu, and FTP would stand for the file server, and then rockvalleycollege.edu, so that would be the host name, and then rockvalleycollege.edu would be the domain name portion of it. So all of this translates to where IP addresses, port numbers, and domain names are assigned by IANA, the Internet Assigned Numbers Authority, which is part of the Internet Corporation for Assigned Names and Numbers. So they're just a nonprofit organization that oversees this information. So MAC addresses, let's get into it, right? So MAC addresses, they are burned onto the network card. I've used that term a long time because there is actually a number here, and on this one it has a nice little sticker, but on old school and older, and I think it's even though my network card is from 2020, I think it just has a white, so it's just got like a little white number here that says MAC ID. So sometimes you can't, this one's nice because it shows you fairly clear where the MAC address is. So sometimes you just got to really look on it. But it's burned onto that network card. So you can actually look at the network card and know what the MAC address will be. The other way to do it is to open up Command Prompt. So you can open up Command Prompt to find your MAC address. I'll bring that back over in a second. So the MAC address is, again, it's 48 bits long. The first 6 are the organizationally unique identifier, and the last 6 are the vendor assigned. So really this first 6, so we can copy these first 6 numbers, and we can just put it right into Google. I've already searched for it, but you can do, all I did was type in OUI vendor ID, and we can find it. And really, vendor ID I probably could just put OUI in the first 6, and then it would come up with anything. So this is the very first address. I just went straight to it, and I'm pasting those first 6 in there. And you could probably paste in the whole MAC address. So the example that they gave us, the initial registration was in 1998, but they last updated it in 2018. So it's from 3Com. It's the vendor, and you can see where 3Com, and they're in Santa Clara, California, but they're a U.S. company. So you can, and then if you want to look up your own MAC address, it's ipconfig/all. So we do /all, so it'll show the physical address. And you can see there's a whole bunch of physical addresses here. This one's a virtual switch. So I've got VMware working on here, so that's not going to work. We've got my Bluetooth connection, and then here's my wireless LAN adapter. Let's go up one more. Yeah, this is VMware network adapter card. That's not something that's valid because it just is in the VMware software. So we've got my physical address for my wireless card. I'm going to try and copy it. Let's see if that worked. And we're going to paste it. And notice it's dashes. I forgot to point that out, but you can notice it's dashes. It's dashes. So that is there. And then once we look it up, it tells us that it's Cloud Network Technology Singapore. So this is a Chinese technology company that made these. This is a Lenovo computer, and it's a Chinese computer, so that I'm not surprised. Wireshark also has a tool, and it doesn't tell you as much. So look, it just tells you the name and then where it's from, Singapore. I think that's part of the name. Yeah, that's part of the name. I think you can click on, and they give you so when you click on the name, they give you all of the all of the numbers that this company has. It's kind of cool. I like this one. This is the maclookup.app. That one was a nice one. It's the first website that popped up. So, but in the book here, it gave you these links. So the Wireshark link is this one right here. It's the OUI lookup tool. You just paste that number in and hit find. And then, I mean, it's not like there's much difference. And so then they give you examples of MAC addresses. So sometimes it's just the first 4 numbers, period, and then so it's separated by 4s with a decimal, or 2 numbers and a colon, or 2 numbers and a dash. So I've seen all of these at some point. And then the standards, here's all of the OUI numbers and where they came from. We've got microservices, that's from a long time ago. So, you know, we've got every single one. Aruba, FiberHome, Intel, Cisco Meraki. So there's so many of them. So they're all there, and you can go through them all if you really want. So those are there. Those resources are there in the book for you. Those are not outdated links, but you know, you can always search for them if they ever become outdated. And like I said, those last 24 bits, so let's go scroll up a little bit. So we've got the first 24 is the vendor, the organizational unique identifier. So that identifies the manufacturer. And then the last 6 are, so the first 6 OUI, last 6 are the vendor ID. And so it's the extension identifier or device ID. No 2 NICs have the same MAC address. Everybody has a different MAC address. So we just went through and did the identifying. You can actually use Wireshark itself to find the MAC address for you. I just went to, because it's my computer and I have access to command prompt, I just use that. So MAC addresses have a very specific purpose. They are a local area network only. So the switch is able to figure out where to send the information based on the MAC address. So when a switch gets a packet, it will de-encapsulate that packet so it can see the MAC address. So it will go to the layer 2, look for the MAC address information, and then decide where it needs to send it based on its MAC address table. Because that switch has a table of every MAC address. And so it knows where to send it and what port to send it on. So it maps all its ports to a MAC address. So then when the switch, so switch learned all of the MAC addresses, well, it learned most of them, and it can also have a process where it will learn new ones as well. But this message is addressed to, you know, this computer on this port. So this message is addressed to 12:34:56:7A:AB:CD. So, and then they know that that one's connected to port 1, and it will send it to port 1. So, and if this receiver, you know, so it's sending it in, the switch knows where to send it, so then it's going to send. What numbering system do humans use to write MAC addresses? Hexadecimal. And which Windows command? So what did I use? I used ipconfig/all. So that is everything for MAC addressing. And the next video will be IP addressing.